Good morning, my dear students. Today I am going to take under the unit carbonyl compounds this next topic, carboxylic acids. Carboxylic acid is containing the molecule, that is the functional group COOH. So here is containing CO group, that's why it was included under the carbonyl group. Kindly understand this one. So let me explain what are carboxylic acids. Carboxylic acids are formed by replacement of hydrogen atom in a hydrocarbon, aliphatic or aromatic by COH group. Kindly follow. In the case of mineral acid, inorganic acid, so HCl, nitric acid, sulfuric acid, they are different, replaceable hydrogen atom. Here also replaceable hydrogen atom is present, but the group is carboxylic group. Kindly follow. That's why we are calling it as, even though acid, specifically we are mentioning as carboxylic acid. So whenever we say carboxylic acid, you have to assume it is organic acid. So carboxylic acids are formed by replacement of hydrogen atoms in a hydrocarbon, aliphatic or aromatic by COH group. Carboxylic acids may be aliphatic or aromatic depending upon the group, alkyl or aryl attached to carboxylic carbon. Large number of carboxylic acids are found in nature. Some higher members are aliphatic carboxylic acid containing C12 to C18 carbon atom. They are known as fatty acids. Kindly follow. They are known as fatty acids, which are present in our body in the form of triglyceride. Now, next, any topic in organic compounds. So these are the topic we have to discuss. One is test for carboxylic acids, classification, nomenclature, isomerism, preparation, properties and uses. So first, for carboxylic acid, the most important test is action of saturated sodium bicarbonate test. Sodium bicarbonate test. Action of saturated sodium bicarbonate test. That is, you prepare saturated sodium bicarbonate solution, take 1 ml in a test tube and add, if it is a liquid acid, add 1 or 2 drops, solid acid a few crystals. Immediately you can see brisk effervescence shows the presence of carboxylic acid. See, actually what is happening? The general formula, this is the RCOH. It may be aliphatic or aromatic depending upon the R. So when I treat it with sodium bicarbonate, kindly follow. So this H is combining with this HOC3. So converting this to RCOONA, sodium salt of the acid plus carbonic acid. This carbonic acid is unstable to produce water and carbon dioxide. Please follow. So the liberation of carbon dioxide, it is coming out as gases, you are seeing it effervescence. So this is the test for carboxylic acid. All carboxylic acid will answer for this one. The only difference is, in the case of mineral acid, the effervescence is taking place at a faster rate, even the solution will come out from the test tube. But here, the reaction is very, very slow. So you have to see that is with bringing nearest to our eye and you can see bubbles are taking place. So that is the main difference between aromatic carboxylic acid, the aliphatic aromatic carboxylic acid from the mineral acids. The second test, the most important test is esterification test. Esterification test. This we have already discussed under the alcohol. So here acid, so let me give priority for acid first, then we take an alcohol. Kindly follow. So what will happen now? The corresponding ester is formed plus water. This is this. So what you have to take now? Take 1 ml of carboxylic acid or a few crystals of acid, then add alcohol, add concentrated sulfuric acid. Please follow. 1 or 2 drops. Add and heat strongly. Then take 1 drop of this solution add into a water beaker containing water, then neutralize with ammonium hydroxide. Then smell that solution. That fruity odor shows the presence of acid. So aromatic acid normally will give fruity odor. Kindly follow. So if it is in this case, suppose if you are using aliphatic acid, use aromatic alcohol, correspondingly ester will be there. Kindly follow. So this is called esterification test, fruity odor. So the next I will go for classification. Coming for classifications, kindly follow. As usual, all carboxylic acid we can classify into aliphatic and aromatic. General formula RCOH. R equal to CH3, this is aliphatic. R equal to C6H5 aromatic. Please follow. So aliphatic and aromatic carboxylic acid can be differentiated by 3 ways experimentally. We have discussed already under the hydrocarbon, other cases, even the basic concept of chemistry, and in not we repeat again. Coming for aliphatic, we can classify into 2, open chain and closed chain. Open again classified into saturated and unsaturated acid. Coming for aromatic, we can say aryl aromatic or alkyl aromatic. Kindly follow. So with the specific example, let me discuss now. So first, I told you aliphatic and aromatic. Aliphatic, this is 6 carbon atom I am taking, it terminally COH. So hexanoic acid. So this is benzene ring COH, benzoic acid, both containing here. So here 6 carbon atom, here 7 carbon atom, 6 benzene ring and 1 COH. So this is aromatic, this is aliphatic. Kindly follow. Further, saturated open chain compound, further we can classify into with one functional group, formic acid, acetic acid, and with more than one functional group, more than one COH group. So more than one, I have already discussed dicarboxylic acid, kindly follow, oxalic acid, malonic acid, succinic acid, glutaric acid, adipic acid. Simply going on to number is going on. Please follow. Now, coming for unsaturated, kindly follow. This is a specific example. The common name is glutaric acid. So this is 1, 2, 3, 4 butene-1-oic acid or 2-butane-1-oic acid, that is called crotonic acid. Kindly follow. This is the aliphatic unsaturated acid. Instead of CH3, if you put C6H5, nothing but cinnamic acid, aromatic acid. Kindly follow. Now let me come for aromatic acid. Kindly follow. Benzoic acids, aromatic, phenylalastic acid, this is phthalic acid, dicarboxylic acid. Coming for the nomenclature of acids, so common name, as we have discussed already, common name 3 types based on the source, based on the nature of chain, based on functional group. Here functional group always 1, so there is based on functional group we cannot write here. So automatically here we just think of common name formic acid acetic acid, oxalic acid, malonic acid, succinic acid, etc. Common name. And before going for the IUPAC name, the another one based on the carbon chain we can. Say for example, let me take now CS2, COH. This is normal butanoic acid. And another example, CCS3, CH, COH. This is isobutanoic acid. So normal and iso is again common name. Kindly pass based on the chain arrangement. Kindly remember. This is very, very important. You come for the IUPAC name, formic acid, methanoic acid, common name. Acetic acid, common name, IUPAC, ethanoic acid. Then oxalic acid, common name, ethane dioic acid. Please follow, we are retaining E because consonant D is coming. If vowel is coming, we are dropping E as per the rule. This is malonic acid, common name, propane dioic acid, 1,2. That is 1, 2, 3, 1,3 dioic acid. Kindly follow. Then this is, that is succinic acid, common name, butane 1,4 dioic acid. So this is IUPAC name. So coming for the aromatic, benzoic acid common name as well as IUPAC name also common name, that is benzoic acid. This is the structure. Phenyl group and COH attached to benzene ring. Coming for aromatic or under the aromatic carboxylic acid, the other is phenylalastic acid. This is acetic acid, CH3COO. So instead of hydrogen atom, phenyl groups attached, it is 2-phenylalastic acid. 1, 2. 2-phenylalastic acid is IUPAC name. Common name, phenylalastic acid. Coming for our syllabus, phthalic acid is their common name, but I can give IUPAC name as benzene 1,2 dicarboxylic acid. Benzene 1,2 dicarboxylic acid. Kindly follow. So under this, kindly follow. So 1, 2 I have seen. So 1, 3, 1, 4 I will give the name. Kindly memorize. This question may be asked. Common name, isophthalic acid. That is, this is actually IUPAC name, benzene 1,3 dicarboxylic acid is isophthalic acid. Please follow. Phthalic acid 1, 2. Isophthalic acid 1, 3. Kindly follow. The next one, 1, 4. Kindly follow. That is called the common name, terephthalic acid. Normally it is used for the preparation of terylene, terephthalic acid. IUPAC name, benzene 1,4 dicarboxylic acid. Please follow. Now, so next I will go for isomerism. We know isomerism definition. Compounds having same molecular formula but different physical and chemical properties are called isomers, and the phenomenon exhibited by these isomers is called isomerism. Example, we know there are two types of isomerism. One is structural, another is stereo. Structural 4 types: chain, positional, functional group, metamerism. Stereo 2 types: optical, geometrical. So out of 6 isomerism, what are the isomerism possible for carboxylic acid? What are the isomerism not possible for carboxylic acid? Question can be asked. Most important. One among the isomerism is not possible in carboxylic acid. One among the isomerism is possible in carboxylic acid. So I told you already, chain and optical always possible in all types of the organic compound. In all organic compound, chain and optical always possible. Please keep it in mind. Additionally, functional group isomerism possible, whereas positional isomerism not possible, metamerism not possible, Geometrical isomerism not possible. Please follow. This you have to memorize, then only you can answer. So let me give you example of chain isomerism. Example, pentanoic acid. This is 3-methyl butanoic acid. IUPAC name is given. So here why it is called a linear chain, this is branched chain. Kindly follow. Normal and iso. So if normal name pentanoic, that is N-pentanoic acid, this is isopentanoic acid. So chain isomerism. Coming for functional group, the acid will form functional group isomerism with the ester correspondingly. With the esters it will form. The first one is called propanoic acid. Please follow. The second one is called methyl acetate. So let me give you an IUPAC name. Propanoic acid. This is methyl ethanoate. Will you follow? This is the main acid. Ethane corresponding ethanoate, OATE. So this is the substituent methyl ethanoate. Examples of functional group isomerism. Coming for optical, it is always possible. So 2-methyl butanoic acid is a specific example of optical isomerism. Kindly see here. One is R. This is S. I told you already R and S are a configuration predicted by theoretically by Kahn in Gold and Prelog. So in order to write the structure in 2-dimensional board or notebook. So this we will name it as R 2-methyl butanoic acid. This is S 2-methyl butanoic acid. But here when you say optical isomerism, what is optical isomerism? Compounds having same molecular formula but different in optical activity. So by theoretically we cannot be able to predict whether it is plus or minus, but R may be plus or minus and S may be plus or minus. Kindly follow. If R is plus, S will be minus. If R is minus, S will be plus. This is the interesting information now because one is the mirror image of the other. So that they are called enantiomers. Kindly follow. They are called enantiomer. So that means if R is plus means definitely S will be minus. If R is minus, definitely S will be plus. Please follow isomerism. Next, let me come for general methods of preparation of acids. From alkanes, I can prepare acids. Kindly follow. Specifically, long chain alkanes obtained from petroleum can be oxidized to a mixture of carboxylic acid by passing air at 120 degree in presence of manganese stearate. So, long chain alkanes obtained from petroleum. So, cracking of petroleum we will call it as. This is called cracking of petroleum. Please follow. So, from petroleum we can get alkanes containing large number of carbon atom. This is one method. Number two, this we have already discussed under the alcohol as well as aldehydes. So, from alcohol or corresponding aldehyde, by simple oxidation we can prepare acids. Let me say, primary alcohols on oxidation with acid potassium permanganate or sodium or potassium dichromate give corresponding aldehyde and corresponding carboxylic acid containing same number of carbon atom. Kindly follow. This is the general formula. RCH2OH undergoes oxidation, aldehyde, intermediate, then acid. So specific example, I am taking ethyl alcohol oxidation gives acetaldehyde, oxidation, acetic acid. So acetic acid and ethyl alcohol containing same number of carbon atom, that is 2. So this is the main important. So primary alcohol give acid containing same number of carbon atoms. Kindly follow. That means the aldehyde will give same number of carbon atom. Ketone coming from secondary alcohol gives the lesser number of carbon atom. This is you have to keep in our mind. Suppose if we take secondary alcohol or for an oxidation give ketone. This is also coming under oxidation. B. Secondary alcohol and oxidation with acid potassium permanganate or sodium or potassium dichromate give the corresponding ketones, and further oxidation carboxylic acids containing lesser number of carbon atom than original alcohol. So general RCHOSCH3 oxidation gives ROCH3, further oxidation, a mixture of two acids. So specific example, let me take 2-propanol or isopropyl alcohol, oxidation gives ketone. On further oxidation, it produces acetic acid and formic acid, a mixture of two. Both are containing lesser number than original alcohol. Kindly follow. Then third important method is from acid derivatives we can prepare. What are the acid derivatives we have? So we are having ester, anhydride, ester, acid halide, acid amide. So these on hydrolysis will produce corresponding acid. So first let me take now from acid derivatives, from esters. Carboxylic acids can be prepared from acid derivative by hydrolysis with mineral acids or alkali. Alkali or acid hydrolysis gives acid. General formula RCOO R dash water plus H plus or COH R dash OH. Indicating R dash OH, that is the substance connected with the O oxygen atom. So specific example, methyl acetate undergo hydrolysis, acetic acid and methanol. Please follow. This is hydrolysis of ester. Now here, the higher members of the acids we are getting from, we will call it as from the fat. From fats and oils or oils, we can, that is nothing but ester. So simply it is coming under from ester. So this is esters of higher fatty acids. So fats and oils are higher fatty acids, triesters of higher fatty acids. Many esters occur in nature and serve as source for carboxylic acid. So what you are seeing here, this is actually a glyceride, because the original compound is glycerol. So when you hydrolyze this, kindly follow, you are getting corresponding higher, say for example in this case palmitic acid, I am giving example, containing carbon is, kindly follow, 16 carbon atom is there, palmitic acid. If it is same acid, it is called simple glyceride. If it is different acid, it is triglyceride. Normally, when you go for blood test to a pharmacy or the hospital, the report will be given as triglyceride because all the three acids in our bodies are different acids present in the glycerol. Kindly follow. So, the next one, from acid halides we can get acid. From that is, this is also acid derivative. Carboxylic acid can be prepared from acid halide by hydrolysis of mineral acid. General formula RCOCl, hydrolysis RCOHSCl. Say for example, acetyl chloride. So hydrolysis give acetic acid and HCl, it is produced. Very, very easy. The next derivative is from acid anhydride. Kindly follow. I told you acid anhydride. Carboxylic acid can be prepared from acid anhydride by hydrolysis with the mineral acids. This is the general formula giving this general acid. So specifically, this is acetic anhydride. I can write the structure like this, then you can easily understand this. Kindly follow. This is the actual structure written in this form. Acetic anhydride. Kindly follow. So what will happen when it is undergoes hydrolysis? Kindly follow. OH is going here and H will coming here. Produce two molecules of acetic acid. So acetic anhydride will give on hydrolysis two molecules of acetic acid. Please follow. The next, from acid amide, we can prepare acids. Acid amide. Carboxylic acid can be prepared from acid amide by hydrolysis with mineral acids. So this is general formula. RCONH2 undergoes hydrolysis to give acid and ammonia is liberated. The specific example, acetamide. So giving on hydrolysis acetic acid and ammonia. So here it is undergoing hydrolysis HOH. Kindly follow. Acetic acid and ammonia are liberated. So from acid derivative, that is the third method. The fourth method, from nitrile, nothing but cyanide. General formula RCN. So any cyanide on hydrolysis will give finally COH group, acid group. So carboxylic acids can be prepared from nitriles by hydrolysis with the mineral acids. Specific example RCN converted first into intermediate RCONH2, further hydrolysis the RCOH and ammonia. Specific example methyl cyanide or ethane nitrile IUPAC undergoes hydrolysis to give acetamide, further hydrolysis acetic acid and ammonia. Please remember, from cyanide we can prepare carboxylic acid. The another most important method is Cricknod reagent. Kindly follow. Cricknod reagent, this is again general method. You can apply any acid you can prepare from this. So that depending upon the Cricknod reagent, you can change the acid. So Cricknod reagent reacts with carbon dioxide. This is actually, you can say, action of carbon dioxide to form salts of carboxylic acid, which in turn give corresponding carboxylic esters, exception formic acid. So formic acid we cannot prepare by this method. Please follow. Question can be asked. From Cricknod reagent, formic acid we cannot prepare. Then after acidification with mineral acid we are. So you take general formula RMgX, adding the correspondingly carbon dioxide. So what way it will undergo this phase? So this is the intermediate formed. Hydrolysis giving acid and MOHX. This is the general. So let me take a specific example. You can understand that. Kindly follow. Methyl magnesium iodide, a specific common reagent used in the laboratory, reacts with the carbon dioxide to form salt of carboxylic acid. That is, this is the salt of carboxylic acid, which in turn give corresponding acetic acid and MgOHI. So as usual, how it is taking place? This is the simple addition reactions. Kindly follow. This is the intermediate. And this on hydrolysis gives acetic acid and Mg. Kindly follow here. Cricknod reagent, when I use CH3, acetic acid is coming. So carbon dioxide is only converted into COH group. So whatever acid you want to prepare from Cricknod reagent, you take that R, Cricknod reagent R, corresponding you will get it. Suppose I want, instead of acetic acid, propanoic acid I can use ethyl group. Ethyl magnesium iodide I will use. Suppose I want benzoic acid, I will use C6H5. Phenyl magnesium iodide I will use. So any acid I can prepare. That's why general method. So I hope this is enough for general method of preparation. Coming for properties. As usual, first physical properties, then I will discuss chemical. The 9 members are colorless liquid. Starting from formic acid, acetic acid, propanoic acid, 9 members are colorless liquid at room temperature, while higher members are colorless waxy solid. Carboxylic acids are generally having higher boiling than the corresponding alcohol or aldehydes or ketones. Lower members are soluble in water, but solubility decreases with increasing molecular weight. Kindly follow. Coming for chemical properties. So this is a very interesting in this carboxylic acid. Kindly follow. So we have, this is the functional group. So here, reaction due to hydrogen atom, it will take place. Then reaction, the whole OH group that can, and reaction as a whole COH group also we can classify like this. So let me discuss now. Reactions of carboxylic acid can be broadly classified into 3 types. Reaction involving H of OH group, I told you. Only hydrogen of OH will react. Reactions involving OH of the carboxylic group. And third, reaction involving H of alpha carbon also it will react. Additional to that. Please follow. Alpha carbon with respect to carboxylic group also it will react. And the carboxylic acid whole as a react. Kindly follow. Now, let me take first example, reaction involving cleavage of OH bond, that is action of metal. Example, carboxylic acid reacts with metals like sodium, potassium, calcium and zinc to produce corresponding salts with the evolution of hydrogen. General formula RCOOH plus Na, arrow RCOONA plus of H2. So acetic acid, specific example, reacts with sodium, gives sodium acetate and half H2. Please follow. So suppose you don't want half H, simply multiply by 2, the entire thing, 2 acetic acid, 2 sodium acetate, H2 gas will be formed. That is for the stoichiometric point of view. Kindly follow. The main aim is hydrogen gas will be liberated. You can use as a test for acid also, this you can use. So only hydrogen is reacting. The second is action of bases. Kindly follow. Carboxylic acid reacts with inorganic bases to form corresponding salt. Example, sodium hydroxide. General RCOH, sodium hydroxide, RCOONA and H2O. So hydrogen is substituted by sodium. Specific example, acetic acid reacts with sodium hydroxide to give sodium acetate. Hydrogen is substituted by H plus is substituted by sodium plus and water. So this is action due to hydrogen atom. Continues. Kindly follow. Action of bases. Kindly follow. Action of bases. This we can even use as a test for acid. All carboxylic acids react with sodium carbonate and sodium bicarbonate in dilute aqueous solution to form sodium salts of acid with the liberation of carbon dioxide. Kindly follow. So in the case of acetic acid, 2 moles sodium carbonate reacts to give 2 moles of sodium acetate, water and carbon dioxide. So liberation of carbon dioxide, you can see it as a brisk effervescence. The same way acetic acid reacts with sodium bicarbonate, giving sodium acetate, water and carbon dioxide. This I have already discussed under the test for carboxylic acid, where I used saturated solution of sodium bicarbonate. Kindly follow. The next, under this reaction involving cleavage of OH bond, kindly follow. Calcium salts of acid on dry distillation gives aldehyde or ketone. Please follow. And also, electrolysis of concentrated aqueous solution of sodium salts of acid give corresponding hydrocarbon. Kindly follow. This is the most important reactions. So, the breakage of hydrogen bond, it is taking place. Okay. Next one. Reactions involving cleavage of OH bond. OH is reacting. Specific example, action of diazomethane. Formula CH2N2 that we can prepare in the laboratory itself. It is unstable, so we have to prepare at the spot and we have to use. Carboxylic acids react with the diazomethane to produce corresponding esters with the evolution of nitrogen. Kindly follow. So what is happening now when it is treated with the methane, the H, kindly follow, it is converted into CH3. Kindly follow. That means the N2 hydrogen gas is liberated. Same acetic acid is converted into methyl acetate and nitrogen is getting evaporated. Kindly follow. Next one. Continuation of this reaction. Carboxylic acid, action of heat. This is the most important. Carboxylic acid on heating with mineral acids such as sulfuric acid, P2O5 giving corresponding anhydride. Anhydride. So general formula R2RCOOH corresponding anhydride water. Specifically 2 moles of acetic acid give acetic anhydride. Kindly follow how it is forming. This is acetic acid. This is also acetic acid. So when you are heating, what is happening? It is forming, eliminating water, forming this acetic anhydride. Water is formed. So any 2 acid like this would eliminate water to give corresponding anhydride. The reagent is either sulfuric acid or P2O5 without dehydrating reagent. Please follow. Next one. Action of alcohol, that is test for acid, esterification test. Alcohols react with the carboxylic acid in presence of consulfuric acid to form ester. A specific example, general formula ROH, R-COH, so that R-COO, R I am writing. Please follow, only acid will be writing in the left hand side, alcohol will be written on the right hand side. So specific example, I am taking acetic acid, I am treating with methyl alcohol, so methyl acetate is the ester form. The most important information, normally what we are following, in the reaction, the hydrogen atom of carboxylic acid reacts with the OH of methanol, that's only we are thinking. But from the mechanism, it was identified only O, that is H of methyl alcohol, kindly follow, and OH of acid is reacting. It is proved by experimentally, please remember. It is proved experimentally in the mechanism. So that is OH is involved, cleavage, methyl acetate. This is studied by the radioactive oxidation. Kindly follow. The next important reaction is action of phosphorus halide. So under these 3, trihalide and pentahalide, as phosphorus trihalide, as phosphorus pentahalide. So this is the general formula. So let me take specific formula. So if I take 3 molecules of acetic acid and phosphorus trichloride, I am getting acetyl chloride and phosphorus acid. Please follow. This is always very, very important. Whenever you suppose an alcohol or acid, when OH is substituted by PCl3, always phosphorus acid is formed corresponding to the acid alkyl halide or in this case acid chloride. The same way in the case of acetic acid, PCl5 when we use, again acetyl chloride, same product, but instead of phosphorus acid, phosphorus oxychloride and HCl is formed. So this you have to memorize, please follow. That means PCl3 phosphorus acid, PCl5 phosphorus oxychloride. Other 2 are common. The action of thionyl chloride, pure method. Carboxylic acid undergoes substitution reaction with thionyl chloride to produce pure acetyl chloride. This is the general formula method. I can take specific acetic acid example. When you treat with iron and chloride, what is happening? Acetate chloride, sulfur dioxide, HCl. These are all gases escaping away, leaving acetate chloride in pure form. Please follow. That's why this is called pure method. Then, action of ammonia. Carboxylic acids react with ammonia to produce ammonium salt first. On heating further, at high temperature, give corresponding amide. So, this is the general formula. So, specific example, acetic acid, let me take ammonia. So, what will happen now? First, the H is combining with the NH3, forming NH4. And then from that, what is happening now? That O also going out in the form of the water and leaving NH2 group. Kindly follow. From NH4 there is H2, here O, it is leaving 2 hydrogen atom and O is going out in the form of water. So producing acetamide. That's why this is coming under cleavage of OH. Please follow. Reduction. Another important reactions. Carboxylic acid undergo reduction to primary alcohol by powerful reducing agent lithium aluminum hydride, or better with diborane. Diborane we know already, studied all, that is under the boron family. Sodium borohydride does not work. Please follow. This is the general format from acid directly converted into alcohol. Let me take acetic acid, product is ethyl alcohol. Same number of carbon atom. Kindly follow. Just see here is the reverse of oxidation. Kindly follow. Alcohol oxidation gives acid. This is acid undergo reduction, alcohol. Same number. So only thing is reagent. In the alcohol to acid, potassium dichromate, acid potassium dichromate or permanganate. Here lithium aluminum hydride is the specific reagent for reduction. Under the reduction, I can go further. Carboxylic acid lose carbon dioxide to form hydrocarbon when their sodium salts are heated with soda lime. What is soda lime? It is a mixture of sodium hydroxide and calcium oxide. This is soda lime. Kindly follow. This reaction is known as decarboxylation. Whenever you want to remove any carbon dioxide from acid, the corresponding hydrocarbon will be produced. This is the general reaction. Kindly follow. So let me take specific example of acetic acid. Say for example acetic acid. So when I heat with sodium hydroxide and calcium oxide, sodium hydroxide will convert into sodium acetate. Then in presence of calcium oxide, this will undergo decarboxylation to produce, converted into carbon dioxide. So after the react with sodium, correspondingly sodium carbonate is forming and methane will be produced. So kindly follow. This is the most important reaction. Is called decarboxylation. The next type, reaction involving hydrogen of alpha carbon. Please follow. This is the name of the famous reaction. This we have already come across under the halogen. Olgath-Zelensky reaction. H simply we will give is HV is that reaction. Olgath-Zelensky reaction. Carboxylic acid, kindly follow, having alpha hydrogen or halogenated at the alpha position on treatment with chlorine or bromine in presence of small amount of red phosphorus to give corresponding alpha halocarboxylic acid. This reaction is called Olgath-Zelensky reaction. Normally this is used for the preparation of lactic acid. So this is the general method. RCH2COH, X2 represents of red phosphorus, and alpha carbon, that is hydrogen, X is substituted. So let me take specific example, propanoic acid. So in the propanoic acid, this is alpha, with respect to carboxylic group. So bromine in presence of red phosphorus when we are heating, so hydrogen atom is substituted by Br and the HBr is formed. So this is the specific because the Br can be substituted by any functional group. Suppose it is substituted by OH, it is lactic acid. Please follow. So this is called Olgath reaction. Please remember. Next one. Reaction involving hydrogen of alpha. That is, in this case, I can take now action of halogen in presence of light, sunlight or UV light. Carboxylic acid having alpha hydrogen or halogenated at the alpha position or treatment with chlorine or bromine in presence of UV light. So acetic acid on chlorination is producing monochloroacetic acid, further dichloroacetic acid, and finally trichloroacetic acid. All the alpha 3 hydrogen atoms are substituted by this. So this is the most important. So let me come for uses. First, formic acid. It is used as a coagulating reagent for rubber latex. Normally, for rubber tree, it is available in Kerala side. So what will happen? They will collect the liquid from this tree, and on this liquid called latex, and this latex in a suitable vessel they will add, and then add formic acid or acetic acid. It will become hardening, becoming rubber-like. Kindly follow. It is also used as an antiseptic in medicine. In textile industry, it is used for dyeing. It is also used for storing and generating carbon dioxide. The next one, acetic acid. Kindly follow. It is used as a coagulating agent for rubber latex. Formic and acetic acids are used as a coagulating agent. It is used as a solvent for many reactions. Acetic acid is a common solvent for many reactions. In textile industry, it is used. In medicine, it is used as a local irritant. It is used as a reagent for many organic compounds we can prepare from acids. Kindly follow the acetic acid. Kindly follow. So, I can come to the conclusion. So, my dear students, thank you very much for the kind cooperation given so far. If you are viewing for the first time in my channel, the channel is Neat Chemistry by Dr.R.G. Dear student, kindly click subscribe button and share with your neighbors. One important information I want to give, this you can share with your friends. This channel I have started some 2 months before in order to help poor students of India. So normally students find difficulty physics, chemistry and maths to understand the theory. So as a chemist, I want to give freely to educate these students to improve their knowledge. So if you follow systematically the theory, as well as I am going to discuss in future questions also from 5 important question papers, NEET, IIT, AIMS, AIPMT, MSET, Andhra. I am going to take 10 questions from each from the previous question paper for each unit, so that if you follow along with this theory, you will easily get 100 out of 100 in not only in board but also in NEET entrance examination, 180 out of 180. Please follow. So kindly don't forget. And also another important thing, even 8th, 9th and 10th students also can view the video, because I have added all those chapters, 8th, 9th and 10th under the basic concept of chemistry. Please follow. So coming for the other side, students who are waiting for NEET entrance examination conducted by Government of India for this academic year, that is +1, +2 completed students. For you, I want to give the most important informations. We are running a coaching center, Vetri Coaching Center in Pondicherry for the last 20-21 years in Pondi, which is successfully. And we have our own site, website, Vetty Daughters. And if you enter our Vetty Daughters site homepage, you can see all our achievement from the beginning up to 21. Everything in the homepage. What are the achievements we have? Let me point out one or two achievements. Number one, in 2003 itself, our student R. Srinivasa Raghavan came All India first rank in JIPMER, medical entrance examination. At that time, NEET common entrance examination was not there. The second most important achievement is every year 10 to 20 students are going to joining JIPMER Medical College. 150 to 200 students are joining other medical colleges through government quota. And a few students are joining IIT regularly, and hundreds of students are joining other engineering colleges after studying with the Vetty Coaching Center. Please follow this. You can verify from our website, Vetty Daughters homepage. Now I want to give the students who are doing +1, +2 and +3 the best method. You can start with the +1. So our NEET Vetty Daughters in these pandemic conditions, the online, the schools are closed. So you can, by studying Vetty Daughters, interacting with Vetty Daughters, you can get minimum 600 to 700 marks. I can give guarantee for that one. So what are the important features of Vetty Daughters? I will explain. So it contains, kindly follow, 200 video lesson, 200 unit test. Please follow. The 200 the video lessons are taken by the professors with a doctorate degree and 20 to 30 years of teaching experience, IIT, medical coaching, and also they are teaching for BSc, MSc, MPhil and PhD students. They will give very clear idea, the concept, theory, everything very nicely like home, that is classroom atmosphere. If you view the video of Vetty Daughters, you can feel the classroom atmosphere. And also another important advantage there, when we are viewing the video, everything, all the notes are coming on the video. If you want to take any unknown information, formula, definition, or any diagram, please click at the center, the video will stop. You can take the notes or a screenshot. Then again touch, it will continue. Please follow, very, very easy. Very, very easy to follow this one. So easily you can follow the lesson. And another important thing is we have 200 unit tests. That means 50 tests for each subject. That means 25 first lot, +1, +2, another 25 again second test. So each unit, say for example, carboxylic acid, we have 2 tests. Test 1, test 2. Why we are giving 2 tests? There is a purpose for that. So let me explain how to attend the entrance, the model exam, in the Vetty Daughters unit test, how to write. Then you can understand why we are giving 2 tests. Let me take now. How to attend the test. So if you enter Vetty Daughters, joining Vetty Daughters, it is a very low cost, only 10,000 rupees per year. Please follow, when compared to other online coaching, they are collecting in lakhs. So it's a low cost, per subject 2.5 per year. It is lesser than your tuition fees. So, but you can, an 100% guarantee, a very good student get 600 to 700. Even a dull student get minimum sub 500. I can give assurance. Okay, let me come back. Now, when you enter inside, there is a menu called test. If you click the test, whatever unit you want, so for example, carboxylic, the carbonyl compounds, you click the test. There is an attempt menu. You click the attempt, your window will open. Your window will open. In the window, there you can read there. This unit contains 45 questions. Each question carries 4 marks. There are 4 options. Only one option is correct. For each correct answer, 4 marks awarded. For each wrong answer, -1 the marks subtracted. That is, are you ready? 45 minutes is given for time. Are you ready? It will ask. Then if you are ready, take a notebook and pen, rough notebook, to work out the problems, anything. Then click OK. Immediately a window will open. Please follow. In the window, you can see question number 1. Then option A, option B, option C, option D you can see. And also you have 3 menus. Kindly follow. Left side reverse, center complete. This you have to touch only after 45 questions completed. This is the next. So using the menu next, you can go for the next question. Complete after finishing. Reverse if you want to come back. Now kindly follow. Here there is a clock is running from 45 minutes going down below 44.59, 44.58 like that. So you can see time also directly. And below this there is 1 to 45 numbers will be there, which are in yellow color. Yellow color. Please, everything you can see in the window. This provision is not available in any online coaching. Please follow. What is the advantage of this one? You can feel now. You can follow now. When I discuss, you can understand. Suppose you are reading the questions and you feel A is the correct answer. Then you click A. You click A. Immediately what will happen now? The 1 to 45 question number 1 will change into green color. That means you have attended question 1. Question 2 will be blue color. That means immediately you are going to attend 2. All the other will be yellow color. Suppose after 20 minutes, after attending, you can see, for not to save time, you can see there, easily you can assess how many greens and how many yellow it is there. From the number itself, you can identify easily. This provision is not available in any online coaching center in India. So after completing all the 45 questions, you assume that all the 45s are green. Kindly follow. Then click complete. You will get immediately your marks. You can get marks. Say for example, you are getting 140 out of 180 because 45 question into 4, 180 maximum. Out of you are getting only 140. So 40 mark you are losing. Please follow. So if you go on other online coaching center, what you can observe, only this thing you know. So if you want to know, they will give solution. They will give, if you press solution, it will go one of the option which is correct. There will be one word or one line will be given as solution. That's all. But ours is different. You can assess yourself which question you have done mistake, which question you have done correctly. What way? The next to the mark, there is a menu called review. Review menu will be there. Review is the way. You press the review menu, what will happen? Immediately, kindly follow, a window will open. A window will open. In the window, kindly follow, question number 1 will open. You can see option A, option B, option C, option D, and correct answer is given here in the yellow color. Here you have answered in the A is the correct answer, that is in blue color. And below there is a video solution. Please follow, this is not available in any other online coaching center. Entirely different this is unique. How it is unique? Your answer is in blue color. Correct answer is in yellow color. Compare. If they are same, your answer is correct. If they are different, your answer is wrong. So you can assess you have done mistake in this question. In which question you have done mistake, you can identify. That is not possible in any other online coaching. As a whole, you can identify the answer. That's all. Please follow. See, another most important information here is a video solution, which is unique from other online coaching. They will give only one word or one line typed material. Here, video solution. So, video will run nearly 10 to 15 minutes. It will run. Please follow. The experienced professor with the doctorate degree will take class, like classroom. They will stand in front of a board. Question you can see, option you can see. He will read the question, he will read the option. Then he will explain what topic it is asked, what subtopic it is asked, what is the definition, what is the formula you have to apply, what is the diagram it is required. Everything he will explain. The theoretical background. And the short route, technique also he will teach you. So these facilities is not available in other online coaching. So by writing these tests, please follow my dear student, this is the most important. So you are writing test 1 first. After reading your book, after reading our lessons in the .s, you are getting 140 out of 180. When if you read the solutions, you take a notebook and write the topic and the question number and take the whatever information is new to you, formula, definition, anything is new you can note. And the technique, short route, everything is note. Then after finishing this, it will take 2 to 3 hours. After finishing this, you go for the immediately second test. The same topic, second test will be there. Immediately you write, you take another 45 minutes, spend for it. Now you can see from 140, you can go to 170. Kindly follow out of 180. That means this is self-assessment. You can improve your quality. That's why we are giving simultaneously 2 model tests. All the question papers are taken from previous years, IIT, AIMS, AFMT, MSET Andhra, AFMC, etc. So only from this in NEET examination, approximately 75 to 80 questions are repeated. Kindly follow my dear student. This is the important features of our NEET. So we can, I told you all is the low cost, only 10,000 rupees. Any even poor student can offer for the whole year. And even you can partially, you can pay 5,000 also you can pay. Kindly follow. In this idea, so how to pay 10,000? Pay rupees 10,000 in the name of Santi, Director of Ethics Coaching Center, Indian Bank, account number 712719471, IFC code ID B000P134, cell number 9894176425. So thank you, my dear student, for the kind cooperation. I will see you again in the next topic. Bye-bye.